Hello, this is a really quick test of how to process data, fnir data from a 16 channels sensor from an nBack test. This is an nBack test, working memory test, where we have each test is repeated 7 times from 0 back to 1 back, 2 back, 3 back. So this is not a complete introduction to fnirSoft. This is just to show real quickly how it looks like and how easy it is to work with. I will now first open my data file. This is the data file that we get right from Kobe Studio, the acquired data file. And it will ask me, do I also want to load the markers, the associated marker files? And of course I want to do that. I'll take that one. And I can, in all these lines are the actual markers from the nBack test program as well that we have acquired through the parallel port. I will remove them or toggle them just for visibility. I will do refine. The first thing I will do is apply a low pass filter. There's a lot of artifact handling you can do here, and I will just apply a low pass filter. So you see, you will clean it up a little bit. And what we see here are the raw signals files from the 2 wavelengths and the ambient light sensors. So the next step is to from this calculate the actual oxy and the deoxy data files. I will use a default baseline, which is like a global baseline at the beginning of the experiment. And I will use the refined data. So this is the oxygenated data. The blue one is the deoxy data, and the red one is the oxy data. And next I will define the blocks from the markers. And now the way we have done the experiment is that the start of the nBack test, or sorry, the 0 back test is using marker 90, and it stops with marker 98. And this I will label 0 back, run, save. So this here, it marks all the segments or blocks which are the 7 repeats of the 0 back tests. And now I will just repeat this for the 1 back and the 2 back, which is then using marker 92, 2 back, and 3 back. Oh, there. So these I have all the blocks. I will save this to data space, something called data space. No, I will just take the blocks, yeah. So what can we do now? Now I can directly go to, now we get a lot of variables here. We have the oxy data and we get the total hemoglobin. I will just look at the oxygen data now, all of these blocks, and view them like this. And we can, instead of all these labels, the various repeats of the nBack and 2 back tests, we can auto group them. So it means it groups them. The blue one is the 0 back, and the yellow one is the 1 back, 2 back, 3 back, etc. But now you see that this doesn't quite look like we expected, and there's a reason for this. It's because we use a global baseline, and for a long test that's 40 minutes, we need to take the baseline for each block, just the first seconds of the test. So I will do another thing. There's something that you can do afterwards as conditioning called correct baselines. So instead of the global baseline, we will use for each block its own respective local baseline, which is just at the beginning of the test. And this will then make a lot more sense. Oxy local baseline. I will just enter a label there and put execute, and now we would look what we got at the end of the list. This is what we just got, and now we will look at this instead, and we will use auto, and I can also aggregate them. And now you see that now the result is what we expect. So this also shows how important it is to pay attention to the baseline, because in the previous test when we used the global baseline, because this is a 40-minute file, at the end of the test we were still referring to the baseline, which was like 30-40 minutes ago, and this really doesn't make much sense. So now when we are using the local baselines, we see results from the 0-back, 1-back, 2-back, 3-back, where we increase the load on the working memory. We see also an increased level of oxygenation, which is what we expect theoretically. And basically this shows how really easy it is, and also shows one thing that it's important to note, that what baseline you're using. Just one other thing, we can also visualize this. I will do one more thing. I will go back to data space, and I do another average. I will want to look at the 3-back tests. I will average cell by cell, and I want to average all, show labels, all the 3-back tests only. So I want to visualize the dynamical process of the 3-back tests. That, and we will just call it something 3-back ever, like that. And it's now in the bottom here, and then we can go to the something called the top graph. I will load this file there, and I will choose interpolated borderline and brain view, and this is the topological image of our typical stock brain, and we will just overlay here. I will also play back this in 4 times the natural speed, because the process I'm about to show here as a video is, in reality, it's 1 minute long. Now run it in higher speed, and we can also adjust the thresholds here. I will restart it. So this represents the average process of the 3-back test, the average from 3 repeats of the experiment. So you see here, and if you were to repeat this video, compare the 3-back and the 2-back and the 1-back, you will see that the aeration or the oxygenation level increases the higher end you get. Okay, that's it. So I'll stop there.